Okay, guys, so we're doing this question on the left today. All right. This was the classwork that we did in the last class. So I'm just going to go through now and work through the question. All right. Yeah. So this was a quadratic function that was given and actually gave us the graph without giving us any of the coordinates on the graph. They gave us a function on the graph and they pointed us to points A, B, C, D, which are the critical points. We know A is a y-axis intercept. B clearly is that minimum vertex point. C and D are the points on the x-axis intercepts, which are also called the roots. And then they gave us that vertical line. That vertical line, it is a line, it's not a point, right? Because some persons answered that question as if it was a point. It's a vertical line passing through B. B is a minimum point. So the vertical line which passes through the turning point is the axis of symmetry or the line of symmetry. All right. And I wanted us to find the coordinates for each of those 4 points and also to give a name or phrase which is used to describe each point. All right. I actually did an example before you had your chance to do it. And the question was fairly well answered. A lot of persons did it well. Some little minor mistakes that we can learn from. And how we present our answers also. So for example, some questions where the question said give coordinates versus we're given either just the x coordinate alone or the y coordinate alone. So if it says coordinates, you have to give the x value and the y value. All right. So let's go. So the function, and I think 1 or 2 persons actually completed the square, which was not required for this question. You don't need to complete. The question did not ask us to complete the square. It's just asking us for coordinates. All right, so there was no need to complete the square. All right, if we know how to find those coordinates. All right, so the function is f of x equals 2x squared minus 5x plus 2. Now we know if we're going to find, for example, the xt value, we're going to need the a, the b, and the c. All right, if we're going to find the roots, a, b, and c maybe can help us as well. The y-axis intercept, the c, is the y-axis intercept. So we know we're going to need the a, the b, and the c. So we can make a note of that from now. All right, so the a equals 2, which is a coefficient of the x squared. And the coefficient of the x is the negative 5. And that is given the letter b. So b is negative 5. And the c term, c is given to the constant term. C equals a constant term, which is 2 as well. All right, so we're going to do 1 point at a time now. All right, so the first point is A. So we're going in that alphabetical order. So the first point is A. All right, and A we know is A is called the y-axis intercept. A is the y-axis intercept. And you have to look how this word is spelled. It's not intersect. It's a point of intersection, but the word is intercept. To spell it correctly. You don't write the right thing in the exam, you're not going to get the marks. So it's a y-axis intercept. All right. So it's where the curve intersect the y-axis, but it is called an intercept. And the coordinates for that point, that's the name of it, This is the name of it, right? So that what we have written is the name of it. So I've written the name first. That's the name. And then the coordinates now, coordinates would be 0 and the c value, right? And that would be 0, 2. What we do sometimes is put the letter in front. So say A is the point 0, 2, which not well 0 c first. We're saying it is 0 c, which then means that that point would be 0, 2. And these are our coordinates. X coordinate is 0, y coordinate is 2. Coordinates. which is what the question wanted. All right. Then we'll go to the point B, the name and the coordinates. Then we'll go to the point B. So B now is the minimum, it's a minimum turning point or a minimum vertex. B is a minimum turning point or we can call it a minimum vertex. Right? And this now is the name or phrase of it. These two are the name or phrase of the point B. And then the coordinates now, coordinates of B, color. Coordinates of B is xt, yt. Xt is the x value at that turning point, and yt is the y value at that turning point. And we have a formula to calculate each of those. All right, so we need to calculate xt and calculate yt, so we can put them there. So we need to work them out so we can put them there. Let's work them out in a different color. All right, so the xt that we're working out, we can say where. So we're working them out now. Where the xt is equal to negative b divided by 2a. It's a formula that we just need to know. We have to know the formula. All right. And we put on this minus first, as usual. And then the b, the b itself is negative 5. So put down negative 5. We can put that in a bracket, or we can leave it without the bracket. In any case, we know it's minus, minus. And we divide that now by 2 times a. So it's 2 times the a value, which is 2. So the minus minus here makes it a plus 5. So it becomes a plus 5, which we just write as a 5 over 4. And so we know that the value for xt is 5 over 4 right here. Is what that turning point. Now we need a yt value. There's a formula for that as well. So let's go for the blue again and work out the yt value. So the yt value that we need, the formula for that one is 4ac minus b squared divided by 4a. That's the formula for yt. All right, so we're going to put the values in there now, put them in carefully. And this is where some persons made mistakes with the negative value stuff. So, let us get clearly how you put these values in. When in doubt, put the values in bracket. All right, so the 4 first, and the a is 2, put it in a bracket. The c is also 2, put that in a bracket. Minus, that minus is this one, that is not squaring. And this is where some person making mistake now. It is a negative 5 squared. So we're squaring the negative 5, but we're not squaring this minus. So that minus is going to remain as a minus. And then you divide that by 4 times the a value, and the a value is 2. All right, so we can say therefore the yt value that we need becomes 4 times 2 is 8 times 2 is 16. All right, so that is 16 minus, and this is now 5, negative 5 squared is 25. Now this minus is this one. And then the negative 5 squared becomes positive 25. And you divide that now by 4 times 2 is 8. And then the 16 minus 25 on the numerator is negative 9. It's negative 9 over 8, which makes sense because the y-axis intercept over here on the graph, you can see is negative, right down here. You can see that it is a negative y-axis intercept. So not y-axis intercept, a negative yt value. All right, so we get that value. All right, so we now know that this yt value, which is y about the turning point, is negative 9 over 8. And if we write in red, these are our coordinates, right? So it's fit. These are our coordinates. All right. And that's that. The next points, the points that we need next, we need the C point and the D point. But because those 2 points are found in the same way, and they are called the same thing, just that there are 2 of them, we're going to calculate both of them the same way and at the same time. That's now the C and the D. So let's move this up. All right. So C and the D. So what happened with the C and the D now? C and the D. That'd be C and the D. Those are the 2 points. Now those points are basically called the roots, or you can call them the x-axis intercept. But for the most part, we tend to call them the roots. Right? But they're also sometimes called x-axis intercepts. And we're still right that. They're called the roots, or they're sometimes called the x-axis intercept. But the name roots is important for multiple reasons, right? And we'll get into that at some later stage. But roots is the main name that is used, but they're also sometimes called x-axis intercept, just like the y-axis intercept. Intercepts. And it's 2 of them, so it's plural. All right, so that is the name. All right, that's the name of it. All right, and then we need the coordinates now. But what we know about those 2 is that, generally speaking, if you want to find roots, you have to solve an equation. To find the roots, you have to solve the quadratic equation. At those 2 points, right? At those 2 points, we know that the y value is equal to 0. Y value is equal to 0. And the function, instead of writing it to the f of x, you can write it as a y equal. So we can say and the y value is equal to 0 at those 2 points. And at the same time, because it's on the curve, the y is still equal to 2x squared minus 5x plus 2. So the y is equal to 0 at those 2 points. And also the y is equal to this at those 2 points. It means that this 0 is equal to this at those 2 points. Because y equals that 0 and y is equals that. So that is why we end up with a quadratic equation that says, therefore, the expression 2x squared minus 5x plus 2 is equal to 0 at those 2 points. And so when we solve this quadratic equation, we're going to be getting those 2 roots, right? 2 x values for those 2 points. And generally speaking, when you solve an equation with an x squared term in it, you get two answers. If you solve an equation with an x cubed term in it, you get 3 answers. If you solve an equation with an x to the 4th in it, you get 4 answers. That's how it goes. All right? If you solve an equation with just x alone in it, like x minus 2 equals 0, you just get 1 answer. You just get x equals 2, because this is x to the 1. So because this equation, the highest power is a square, right? It's a square. That is indicating that when you solve that equation, you're going to get 2 values of x. 2 values of x. The 2 values can be different, 2 values can be the same, and the 2 values can be imaginary. In this case, there are going to be 2 real values. How are we going to be 2 real values? Because there are 2 real points on the x-axis where y value is 0. So you're going to get 2 real values. You're going to get a smaller root for here and a larger root for here. I want to know which one smaller, which one larger. The smaller one is the one that comes first. Remember, x values increase this way, you know. X values increase that way in the positive x direction. So the one that is closer to the y-axis must be the smaller one. So when you find the 2 roots, you have to assign the smaller one to C and the larger one to D. It's nothing random about it, right? It has to make sense. Your calculation and your diagram must match, right? So you can just randomly pick one. You have to assign the correct one. So we're going to solve the equation. Now we can solve the equation using the quadratic formula, or we can solve the equation using factorization. Now I'm going to use factorization because the questions down here, this one needed a quadratic formula. So we're going to get a chance to use a quadratic formula for that one. All right, and these 2 didn't have any quadratic, 3 terms quadratic to factorize. So this was an all opportunity to factorize on this classwork. So I'm going to use the factorization method to do it. All right, so let us look back at the factorization method. All right, so how we do the factorization? Remember now you multiply the 2n coefficient, 2 times the 2, and that is equal to 4. Then you want factors of the 4 that add to the middle coefficient of -5. Factors of a positive number that add to a negative number. If you want factors of a positive number, it is either 2 positive numbers or 2 negative numbers. You want factors of this, which is a positive number. So it's either 2 positive factors or 2 negative factors. Because you want the sum of those 2 factors to be negative like that, you have to use 2 negative factors of the 4. You have to use 2 negative factors of the 4. All right, so basically that's how you know what you must use. I'm just explaining for persons who never weren't so clear. All right, so we need 2 negative factors. We need 2 negative factors right there. All right, so first 2 factors of 4 are 1 and 4. Those are factors of 4, but as I said, both of them have to be negative. And we add these 2 factors of 4, they actually equal -5 already. So we have actually found the 2 factors that will add to the middle coefficient already. So we can go ahead and split the -5. Here, we're going to split it into -1x and -4x. All right, so this is going to become 2x squared. And I'm going to put the -4x first to match it up with the 2x squared that is there. Easier to factorize or more clear. So I'm going to put -4x and then -1x. -1x. I'm going to put the 1. So, you know, you could put -x, but I'm going to put the 1 just to make it clear. Plus 2 equals 0. And some persons tend to be leaving off the equals 0 from the equation. No, get out of that bad habit. If it's an equation you're solving, you need to show the equation all the way down. All right, so some persons tend to be doing that. All right, so we're going to clean up all of those things. So don't worry yourself. So anyway, let's move on. So always do your check right here, guys. And this, some persons didn't do this check to make sure. Always check that what you split this into is equal back to the -5x. Okay, you cannot change the value. You can just change it how it appears to make it easier to factorize. So those two would give me back the -5x. So it means that I can go ahead. And that's the stumbling block for some persons. They didn't do that little check. That's so you can know if you make a mistake right there, you know. So for example, if I made a mistake and I put a plus right here, so I know that this is equal to -3x. That's not what I want, right? And if I do it the other way around, I make a mistake and put a plus here and a minus here. Again, this will just be equal to +3x. Know that I make a mistake as I'm trying to get -5x, right? And you know, just always do that check. Always do that check just to make sure. All right. So that's what we want. All right, so we're going to factorize it now. So you factorize the first 2 terms first. Highest common factor, that is 2x. You factorize 2x out of 2x squared, you're left with an x. And you factorize -2x out of that, you get -2. I would say the same thing to do is to put back the x minus 2 first over here, equals 0. And then you look from the -1x, you factor down the x. So it means that you must have factored out the -1. And that's another place some persons making mistake. It has to be plus something or minus something. Some persons just put a 1. And then when they put the 1, now they end up put 2x plus 1 in the first bracket. And then write x minus 2. So that's a mistake. That's why you have to put something in front there, plus or minus. In this case, it is supposed to be minus. Right? So you cannot just put a 1 there. Right? So it always must be that you put plus something or minus something there, not just something. So this case is -1 you put, and you can check it. The -1 times that is this, and the -1 times -2 is +2. So you know that you're right. Right? And then this and this is the factor that you're multiplying by that common factor. All right, so nice and easy. So we get 2x minus 1 times x minus 2 equals 0. So we should state now we can actually write the two roots. Remember, if this multiplied by this equals 0, then either this equals the 0 or this equals the 0. All right, so but we don't have to write out that all of that at this stage. We're doing CSEC, and then we're not doing question like we're in second form. All right, so let's imagine that if this is the one that is equal to 0, then to get the x, you have to carry over the 1 first. You have to transpose the negative 1 over the other side first, and it will become positive 1, which is just a 1. And then you have to divide under the 2. So you divide under 2. So that's the solution from this side. All right, and then if this is the one that is equal to 0, then naturally you're going to carry over the negative 2 and becomes positive 2. So you're going to write x equals 2. All right, so those are the two roots. All right, so let me erase this. Erase that. Now remember, you have to know which one to assign to which one. Right? So clearly, this one is a smaller one. So this one is for the C value. This one is a larger one, so that one is for the D value. But the question asks for coordinates. Right now, all those are just roots, x values. The question asks us for coordinates, and so we have to write the coordinates. And these are the coordinates. C first. C is the point, you put the x value first, half, and the y value there is 0. And D, the x value there is 2, and the y value there is also 0. So these now are your coordinates that the question asked you for. These are your coordinates. All right, so far so good. And then the next part of the question now asked us, so those are the name and the phrase, the coordinates, sorry, and the name or phrase for each point. The next part of the question now is asking us for the vertical line, the name of the vertical line. So the next part now we're going to be talking about that vertical line. So some persons write it as B, but we're talking about the line itself, not the point B, just that it passes through B. So we're talking about that vertical line on the diagram. Vertical line on the diagram, which is the axis of symmetry. Why is it the axis of symmetry? Because it passes through B. So that vertical line is called the line of symmetry or the axis of symmetry. So it is the axis, I can say line of symmetry. Some persons spell symmetry with 2 M, some persons spell it with 1. It doesn't matter. So that is the name or phrase for it. So this right here is the name of that vertical line. And the next thing now that I wanted was the equation. The equation of the vertical line. The equation of the vertical line is x equals whatever the xt value is. Now some persons do this and put 5 over 4 as if they're solving an equation. No, you can't do that. You're writing an equation. The equation just happens to take this form, or happens to be x equal whatever the x value is, xt value is. So you have to write it. So you say i.e. that equation is x equals the xt value is 5 over 4, right? This thing is the equation, the whole thing right here. So this is the equation of that vertical line. This is the equation of the vertical line. So you can't just put 5 over 4. You have to write it out. X equals 5 over 4 is the equation of the x value at the turning point that passes through the point B. So that was question 1. All right. All right. Let's go down to question 2 now. All of this part is just revision and was revising what we have done before. As I said, we're moving on to something, 2 things today. 2 easy, quick and easy thing. I'm going to practice some of those questions tomorrow. That is the plan. All right, so question 2 part A. Question 2 part A is a factorization. I would say 4 terms there, so we know the factorization by parts, right? So it's 3g minus 3t plus 2mg minus 2mt. All right? So you factorize it. You want to ensure that the values are set out in a friendly manner for the factorization. All right, so you're gonna look. It's almost like you're gonna start the process with these two and see what would happen. If I were to factorize out the common factor, which is 3, I would have a g term followed by a t term. So in the second two now, you want to ensure that you have the g term in front of the t term, just as it is over on this side, which is the case. So because that is the case, there's no need to rearrange anything. Right? There's no need, you can just proceed with the factorization. Do that little check before you start. If that was not the case, you have to rearrange the value so that they set out in that friendly manner to make the factorization easier for you. All right, so we're gonna go and proceed with the factorization. So the common factor first in the first two terms is 3. You factorize 3 out of the 3g, we get g minus t. As I said, put by the same thing in the bracket. That's why I did the check. So you can write by the g minus t over here. And then from a positive 2mg, you factor the g down here. So the positive 2m must come out here. And that's what some persons did. Mistake some persons made. The mistake that some person made is that they just write 2m here and don't put a plus or a minus in front of it. And then when they're ready for the next line, they make a mistake and write 3. They just pick minus. For some reason, put 3 minus 2m. G minus t. That would not have happened if them just put the plus right here and know so this is supposed to be a plus. All right, so I'm just remembering some of the mistakes and letting you know. All right, so go back to the question. So after we factorize, after we write about the same thing in the bracket over here, then we'll look from the g. It's almost like you divide the g out of these two terms, out of this term. And you see that you're supposed to have a plus. You're supposed to have a plus 2m. So you get a plus 2m out here. And then you check it. So you check this times this, which will give you about that. And then you check this time the minus t will give you back that. So you know that it's correct. So that's another thing you want to check. And then it becomes this and this times that common factor of g minus t. And so you write your 3 plus 2m bracket g minus t. So some persons did it away where they get the g minus t in front. Doesn't matter, it is still correct. If you put the g minus t in front, it's still correct. All right, because some persons rearrange the values even though they did not need to rearrange the values. All right, so that is part A. Part B now. So for part B now, we see 3x squared minus 3 to factorize. So that's a quadratics, but it's only 2 terms. So we do have to go into the long procedure. All right, we know it's a quadratic because of the x squared, but we do have to go into the long procedure, as was the case with the 2x squared minus 5x plus 2. Right? So we're thinking about the difference of 2 squares, but the thing is, that's not a perfect square. All right? So initially, it's just a common factor. But we know that sometimes they combine a common factor and a factorization by parts and the difference of 2 squares, and they combine them often. So you have to look out for them, and you have to be sharp and aware. So the common factor here is just a 3. So you factor out the 3, you get x squared minus 1. And you have to look and see if this can be factorized any further. And it can, because you have to remember that 1 is a perfect square. And CSEC like to give questions with 1 as a perfect square. Instead of giving values like 4 and 9 and 16, they like to give 1 because they know that a lot of people don't pick up that the 1 is a perfect square. And you have to remember. So that's a difference of 2 squares in there as well. Right? And so we can write it as the difference of 2 squares. X squared, 1 is the same as 1 squared. And then we're applying the rule. Let's write the rule over here, just for the benefit of those who don't remember. The rule that we're using for this factorization is that a squared minus b squared is equal to the difference of the numbers multiplied by the sum of the numbers. And when you do add maths and pair maths, you're going to get the difference of 2 cubes. In fact, you're going to get the difference between any 2 powers, like a to the n minus b to the n. All of them start with a minus b, and then something else. But for CSEC, it's just squared, and then it's a plus b there. All right? So when you do maths at a higher level, you'll see some of the other things with this. All right, so for now, that is the rule that you're using. All right, so because we're using that rule, we know that our final answer down here now, don't throw away the first factor, which is the 3, and it becomes the difference of the numbers, the x minus the 1, and the sum of the numbers, which is x plus 1. And that's it, we're done. That factorization is complete. All right, then we'll go to question 3. We'll go to question 3. So question 3 gives us that quadratic in a basic form. We know it's a quadratic because we see the x squared term, the x term, and it equals 6. I don't see another variable. And I want us to solve it. Right? So we know it's a quadratic. And we know that we have to put it in the standard form before we try to solve it. But it says give your answer correct to 2 decimal places. Now, why would it tell you that? It is telling us that because factorization is not the best method to do this. Right? The method that we use to factorize, if you try to factorize this that way, you're going to run into problems. All right? So this is one now where you want to use a quadratic formula. That is why they tell you that because the answers are not exact answers. Right? So because the answers are not exact answers, that is why they tell you to give the answer correct to 2 decimal places. So once you see that, don't bother waste time trying to factorize. Right? If you try to factorize this now, you're wasting time. This is like a hint. That statement, giving your answer to 2 decimal places, like a hint to you. They're helping you. They're telling you indirectly that don't bother try to use factorization. Just use a quadratic formula. All right? So let's go. So they give us 3x squared minus 5x equals 6. Remember now that this is basic. We don't solve basic. This is in a basic form. And we don't solve basic. Basic is a no-no when we're solving at this level. All right? When you start the math at a higher level, then you can solve the basic using some other methods. But for now at CSEC, you don't solve basic. So you transpose the 6, you must make it equal 0. So you get 3x squared minus 5x. If you over the 6, you get negative 6 equals 0. When you do that, this is now standard. And this is what we're going to solve. We're going to solve the standard form. Yeah, solving that. So to solve that one, because we're going to use a formula, we need to know the a, the b, and the c. So the a is 3, the b is negative 5, and the c is negative 6. Not 6, negative 6. C is negative 6. And the formula we're using, let's go back for the blue, is that the roots for this equation would be equal to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. That's the formula we're using. All right? That's the formula we're using. So it's a matter now of putting in the values carefully. All right, so I get x equals minus b now. The b is negative 5. You can put the bracket around it or you can leave it. You know that minus minus is a plus. Plus or minus now. This is where a lot of people making a mistake now. Square root. Now you're squaring the entire value of b. So some persons write this minus and they put 5 and then they put the square. You see if you write that, you're only squaring the 5. That's what that means. You're not squaring the negative if you write that. So that's not what you want. So that is wrong. You're squaring the entire b. So put the negative b in a bracket to show that you're squaring the entire b. And it's going to become a plus. And then this is this minus now. 4. The 4 is 4. The a is 3. And the c is negative 6. Now watch me now. Once you see these negative, you have to now become careful. When you see these negatives, you become careful. Why? Because most mistakes in exam questions, when you're doing the right thing, most of the mistakes is just people making mistakes with the negatives. Right? And so you have to be careful. And remember now, you're dividing all of this by 2 times the a value, which is 3. All right? So let's simplify the values now. So it's x equals, the minus here is a plus. So that becomes a positive 5. Plus or minus the square root. The negative 5 squared here becomes positive 25. Some persons ended up with that, which is wrong. Because they never square the minus. You have to square the minus as well. And then this now is negative 12 times negative 6 becomes a plus 72. Right? Plus 72. Plus 72. Now, some person end up with minus 25, one mistake, and then end up with minus 72 because they never wrote the negative here. And then they ended up getting square root of minus 97. Or if you ever try to find the square root of a negative number, the calculator is going to give you some kind of error. Can't work out. So once you're doing a question and you see that square root of a negative number at this level, you know that you make a mistake. Don't even bother continue. You know it's a mistake. Right? And usually the mistake is that you don't square this one and make it positive, or you don't do the minus here. That's usually the mistake. So look out for that. Anytime you get a negative something under the square root sign, you know you make a mistake. All right? So look out for that, guys. So anyway, so let's continue now. That now, we're dividing this now by 6. Because I remember some of the mistakes I'm talking about. Divide that by 6. And if we continue up here, then the x becomes 5 plus or minus the square root of 97 divided by 6 plus or minus. All right, so let me tell you the mistake some people make now when they reach out here. So they break it out, you know, they know that they're going to get one root to the plus and the other root to the minus. So they break it out. So, okay, x equals 5 plus square root of 97 over 6, or the other one is x equals 5 minus square root of 97 over 6. And then, let me tell you how they make the mistake now. They go now and they type this as it is in the calculator straight. So in the calculator, they write 5 plus square root of 97 divided by 6. That's what they put in the calculator. Now, if you type that in the calculator, what will happen is that the calculator is going to do this part alone first and will not divide the 5 by the 6, which the 5 is also divided by the 6. And that's where you're going to get the wrong answer if you just type it like that in the calculator. That is what's going to happen. If you type that like that, the calculator is going to work out this part of it by itself first before it adds the 5, because the calculator is going to follow the BODMAS system. All right? So that's why it is important now is that either you work out the entire numerator value first and write it down before you divide by the 6, or you can bracket this in the calculator, put it in the calculator, and bracket the numerator and bracket that. That is to ensure that you get the entire numerator divided by the 6, like that. All right? All right, let me show you one more thing now. For persons who work it out step by step, remember, you know, you want 2 decimal places, you know. Generally speaking, if your answer is to be 2 decimal places, work with 3 decimal places along the way until you get your final answer. Work with 1 decimal place more than you require, right? Because otherwise, your answer is becoming more and more inaccurate as you go, right? So for persons who worked out the numerator first, and they get 5 plus the square root of 97, 5 plus square root of 97 equals, all right, so they get x equals, let's go back for the purple. So we get x equals 14.8. Now suppose 0 is 14.85 divided by 6. No, don't do that. Your final answer is supposed to be 2 decimal places. So you don't want to be working with 2 decimal places. You want to be working with 3 decimal places, which is more accurate than 2 decimal places. So my calculator is giving me 14.848. So I'm going to write 14.849 divided by 6. So I'm correcting to 3 decimal places as I work. And my final answer, I give it to 2 decimal places, which then will be more accurate. All right, so I need to change this to a minus now. And then I get negative 4.849 divided by 6. All right, and then after a while you won't go step by step in, you just work them out straight. So I get 14.849 divided by 6, and I get, it's a 2 decimal places now, so I'm gonna get 2.474 8 on the calculator. I'm correcting this one, I'm using this to correct this, so I know that I don't need these, right? And then some processes have all of this, with the minus, and still leave off the minus of the answer. And you must have a negative at the answer for the next one. So x equals, I'm dividing this now, which is 4.89849 divided by 6, negative. Right? So it's negative. First, you have to make sure you put down. I get 0.808. But I'm correcting this with this one. So this increased by 1 to 1. All right, that's on my calculator. Correcting to 2 decimal places becomes 81. Those are my answers. Corrected 2 decimal places. That was a classwork. All right, and that also was a quick revision of what we did. All right, so today now, what we're going to look at now is what happens if we actually have the roots and we're trying to find the function. All right, let me give you like a synopsis of what we're talking about. All right, so what I'm talking about is, for example, if you have a quadratic function like that, I know this value is, for example, 3, I know this value is, for example, 6, and they ask you to R of 7, whatever, doesn't matter, and they ask you to find this function. They ask you to find that function. Knowing the roots, how do you get the function? How do you find what the function is? How do you find what the function in form y equals ax squared plus bx plus c? How do you find those? How do you find a, b, and c from that? Knowing the roots. So that's something that I ask in CSEC all the time. All right. There's one additional thing I want to tell. I want you to remind me, which is the relationship between the roots and the x value at the turning point, xt. Relationship between the roots and the xt value. It's actually the average. So since this root is 3 and this root is 7, the x value at the turning point is going to be the average of the 3 and the 10. It's going to actually be 5. It's going to be 3 plus 7 over 2, which is 5. X value right here. So the x value at the turning point is going to be 5. I know that the x value right here is going to be 5. Why is that so? Because remember the axis of symmetry, if you have a curve, a quadratic curve, right? A quadratic curve. And let me put a y-axis here. And that's the axis of symmetry. Remember, since that's the axis of symmetry, the distance from this to this root is the same distance to this root. And therefore, that is why the x value here is the average of the x value here and there. Like a midpoint between the two of them. All right, so the x value turning point is always the average of the two roots. So that's a good information to know. All right, the x value turning point is the average of the two roots because it is right halfway between the two roots. Right, so what we're doing today though is knowing the roots, knowing the two roots, knowing the root 1, we know the other root 2, we know those, and from those, root 1 and root 2, we're trying to find the function y equals ax squared plus bx plus c. Knowing the two roots, how do we find the function? That's what we're doing. And they ask that in from TXR from time to time. All right, so that's the aim for today's class. So there's a method to do it. All right, in fact, there are 2 methods I can show you. There are multiple ways to do it, but there are 2 methods I can show you. All right, I'm going to show you the one that is on the slide first, and then we're going to do a couple questions. In fact, I'm going to show you the 2 ways, and then we'll do some questions, a few questions with the 2 ways. All right, and then you can decide which one you prefer. All right, and it's important to do it 2 ways because you understand the thing a lot better when you have the knowledge of multiple ways. Each thing you learn helps you to understand the overall thing better. All right, so I'm going to show you two methods today. The other method, but I think these two would serve us a little bit more. That thing that I just showed you, two roots, and or the average of the two roots equals x value at the turning point. Also is something good to know. So if you can make a note of it so that you don't forget it when you're revising, make a note of it. It can be helpful when you're solving some questions. Right? How do you get from the two roots to the xt value, the axis of symmetry value? Right? This is the average because remember the axis of symmetry is halfway between the two roots. All right. So this is it. Deriving a quadratic function from the roots. Deriving a quadratic function from the roots. All right. Now let me just show you a little thing before we start. Now remember that we have a function and the function is the whole thing. Y equals ax squared plus bx plus c. Now from the function give you the entire graph, right? The function give you the entire graph or the whole graph. That's right. The function is for the whole graph. I don't want to erase, you know. All right, let me just mark this out. The function is for the whole graph. So the function gives you all points. Whole graph gives all points on the graph. Then from the function, you can get the equation. The equation. And the equation now is when you put the expression. Same values as in the function. You put that equals 0. And what the equation give you? Just give you the two roots alone. So this give you the roots. So that's just 2 points. So the function is giving you all the points, including the roots. But the equation only giving you the two roots. All right. So the equation give you the roots. All right. And then the roots now would be your R1 and the R2 values. All right. So you see that the hierarchy of the system from the function to the root is like a downward thing. So from the function, which is the entire graph, you can go down to the equation, and from the equation, you can go down to the roots. What we're looking at today is that we want to go from the roots back up to the function, right? But the reason I set up this diagram right here because I want us to think of if we want to go back up to the function, we need to go back up to the equation first, and then from the equation, we jump back up to the function. So that is it. So from the roots, we want to first find the equation. And the equation is when it equals 0. That's how I want you to think of working from the roots to the function. And the equation is just now when the thing equals 0. And then from the equation, we want to jump back up and then find the entire function. All right, and this is important. And this is important because you see the equation can be in multiple forms. All right, so but the function has to match the graph. Remember, the function is either a smile graph or a frown graph. And you see the smile graph, it can have the same two roots. Like for example, 1 and 3, as this frown graph can still have the same two roots, 1 and 3. All right, so the equation can help to decide which one you want. All right, so because a function can have the same two roots, a smile function and a frown function can have the same two roots, you have to be careful. All right, so we're gonna see that, and it's built into the procedure what I'm talking about here. So remember, going from the roots to the equation, and then from the equation to the function. All right, so let me continue now. So we're gonna see that built in this. So when the roots of the quadratic equation, when the roots of the quadratic equation are given, right? And we need, when the roots are given, and we need to find the function, we need to derive the function. The factorized form may be used. So this is one method now. The factorized form may be used as follows. So if R1 and R2 are the roots, then we can basically write an equation like this. Remember, the factor formula was A into X minus R1 into X minus R2. That's the factor formula. So I'm saying we can use a factor form like this to write the equation. So basically writing the equation. Remember, the equation now is the one that is equal to 0. An expression equals 0. Right? So we can first start by writing the equation. It's almost like we're assuming that this is the equation right here. And the reason why I don't have the A is because if I divide by the A, it's going to come back down to this equation that you're seeing on the screen anyway. All right. Now from the equation, right, we can put in the roots. And then, for example, if the two roots, we know that the two roots are negative 2/3 and a half. I'm using this as an example now. We're basically put in the negative 2/3 for the R1 and put in a half for the R2. Right? Like that. So note it is X minus negative 2/3, because one root is negative 2/3 and the other root is a half, so it's X minus half. Right? So we have to know the factor form, which is X minus R1, X minus R2. Right? And then now we want to simplify it. The minus minus there becomes a plus. All right, but most times with these questions, they don't want the fractions. They want whole number values. So I have to get rid of these whole number values. All right, so how do we get rid of these whole number values? It's simple. You multiply the factor brackets by constants that will eliminate the fractions. All right, so you multiply the factor brackets by constants to eliminate the fractions, because the questions more than likely will want whole number values. All right, so this is what we do. So that's what we have so far. So what we're going to do to eliminate the 2/3 here, we'll have to multiply by a 3. So multiply that side by a 3 and multiply this side by a 3. And then to get rid of the half right here, we'll have to get rid of this half. We'll have multiplied again by a 2. We're going to apply the 2 to this bracket. And we also multiply this side by 2 as well. All right, so that is a concept. Just to get rid of the factor brackets, the fractions in the brackets. So basically, that is it. So it's like you multiply both sides by 3, but you're applying the 3 to this bracket alone. And you multiply this side by 3 as well. And you multiply this side by 2, but you're applying the 2 to this bracket alone over there. You multiply both sides by 2. But you apply the 3 to the bracket that will eliminate the fraction in that bracket. And you apply the 2 to the bracket that will eliminate the 2 in this bracket. So you have to decide which value you multiply by just to eliminate the fractions. If you do that now, that's what we're gonna end up with. 3x plus 2 bracket 2x minus 1 equals 0. Because on the right side, 0 times 3 times 2 is still 0. But understand that so far? But understand that so far? Just unmute your mic and answer, please.
Yes, sir.
Yes, sir.
All right, good. So that's the equation that we have so far, right? So what we need to do now, we need to expand it out, because remember, we're trying to get the function now in the standard form now. So this is the equation now as if it was factorized. These two equations would have given us the same two roots, but just work backwards from the roots to get to the equation. So we have gotten to the equation. We need to expand the equation out into the standard form now. All right, and that's what we get if we expand it out in the standard form. Now, how can I get this? Remember, the first term times the first term. Oh, sorry, mistake. Hold on. A mistake. The first term times the first term here gives me this. That's how I get the first term in the expanded form. First value times the first value. All right. So I get that one. And then the last value now is the second term. The second term times the second term gives me that value, the negative 2. But to get the middle term, it is the far product and the near product. To get the middle term, it is the sum of the far product and the near product. Gives me the middle term. Now the near product is 4x. You can see that 2 times 2x is 4x, and 3 times minus 1 is minus 3x. And you see that 4x minus 3x is plus x. So that's how we get the middle term. So the middle term is always the one that requires a little bit more work. So remember, the first value in the expanded form is the product of the first two values in the bracket. The third value is the product of the second two values in the bracket, and to get the middle term is the sum of the far product and the near product. All right, so that is the equation now in the standard form. So we have gone from the roots at the beginning, and we have now reached the equation. Remember, we're working back up enough. We're going in the opposite direction. So from the roots, we have gone now, we have gotten the equation. All right, now that we have the equation, now we need to decide now whether we are supposed to have a smile function or a frown function. Because this equation now is an equation for a smile, because the x squared term is 6, which is positive. All right, so this now is a critical step. See here, next we observe whether the quadratic function has a maximum or a minimum turning point. All right, this equation that we have in front of us would be for a smile, because the a squared, the a is positive, the x squared term is positive. All right, so let's go and look. So if our equation would have, if our function would have smile with those two roots, then that would be okay. Because if you notice, the y-axis intercept right here is matching right there. And the a positive, which corresponds with the smile. Right? So this function that we're looking at in the graph, this function is matching this equation that we have here right now. The function that we are looking at and the equation, the match. So when you're doing these questions, they have to show you the function. They will always give you a graph with this question. They'll always give you a graph. Right? So that is it. So right now the match. So because the match, see here, the coefficient of the x squared is positive, which is good. I saw that. Right? So that match. And the equation is therefore valid. The equation is matching this function. And since the equation matches the function, that equation is valid. So all we need to do is put in the f of x or put in the y on the function. And right by the same 6x squared plus x minus 2 means that that is the function for that graph, because the equation matches the function in that case. Now let's look if the graph was a frown graph, if they're giving us a frown graph. So you see, that's a frown graph now with the same two roots, negative 2/3 and half. But this time, if you notice, the y-axis intercept is a positive, right? And we have a negative here, so that don't match. That's one thing that doesn't match. In addition to that, this is a positive x squared, and this is a frown, right? Which a frown is for when you have a negative x squared. So right now, they don't match. They don't match. So right now, the equation is not matching the function. The x squared term should be negative, and there's an easy way to get them to match. Right? There's an easy way. Right? The coefficient of x squared must be negative because they gave us a frown. So to make it negative, we just need to multiply this equation. Just multiply this equation by a negative 1. Multiply each value in that equation by a negative 1, and it will convert it to match. Right? As simple as that. See? So we multiply the equation by negative 1. When you multiply the equation by negative 1, you change the sign of the values. So the 6x squared becomes negative 6x squared. The plus x becomes negative x. And the negative 2 becomes positive 2. Wherein now, this positive 2 now is matching the y-axis intercept up there. And in addition to that, the negative 6, which is the a, is matching the fact that that's a frown. That's a frown graph. So know that this equation down here matches the graph that they gave us. It means that this is the equation for the function. And we can therefore now write the function by just moving the 0 and put the f of x in front of it. As simple as that. Right? So the function is negative 6x squared minus x plus 2. All right? But understand that?
Yes,
so let me do a couple more examples over here now. Let's do these 2 examples. So let's do 2 examples with this. All right, let's do these 2 examples here. I'm going to use those easy numbers now. And what I'm going to do, I'm going to show it. Let me show you the other way first. Right? Let me show you the other way to do it first. All right. Yeah, I'm going to show you the other way first. I'm going to use by the same two roots that we had before and show you the other way. All right. I'm going to use by the same two roots. All right, and show you the other way. Now remember the roots for this was -2/3 1/2, right? Now the other method is based on something. Let me show you the proof of the other method. Now remember that your equation can be x minus 1 root times x minus the other root equals 0. And you can actually have an a in front here. That is the factor form for the quadratic function. But we can divide both sides by the a. And when you divide both sides by the a, that's your function, that's your equation in the factor form, you know. That's the equation in the factor form, right? And that's the equation if you factorize it, right? Okay, and divide both sides by a, and so your equation will be x minus 1 root times x minus the other root equals 0. Now, if I were to expand this out into the standard form with the roots in there, then the x times the x right there would be x squared. The third term would be the minus r1 times the minus r2, which become positive r1 times r2. And then the middle term, remember now, is the far product and the near product. Far product and the near product. Now let's look at it. The far product will be negative, well, let's do the near product first. The near product will be negative r1x. And the far product would be negative r2x. All right, but I give it that. Negative r1x will be the near product, and negative r2x will be the far product. Now, if I factorize the minus x out of these two terms, minus x, right, and minus x. If I factorize minus x from those two terms, I'm going to get minus r1 plus r2 times x. r1 times r2 times x. I'm going to put about the equals 0 up here for the equation. Equals 0. So this will be my middle term. Minus r1 plus r2 times x, based on the fact that the middle term is the far product and the near product. So I'm going to show you it comes out to something simple. You know? So the equation would become minus r1 plus r2 times x. Now, what you notice? Remember, r1 and r2 are the roots, you know, right? What is r1 plus r2? r1 and r2 are the roots, you know. What is r1 plus r2? r1 plus r2 is basically just the sum of the two roots. And r1 times r2 is basically just the product of the two roots. It's just the product of the two roots. And so an equation, a quadratic equation, can be simplified into x squared minus the sum of the two roots times x plus the product of the two roots equals 0. So it's x squared minus the sum of the two roots times x plus the product of the two roots equals 0. So when you know the two roots, this can be the equation. Put a simpler way, it is x squared minus sx, where s is the sum, plus p is the product, equals 0. So this is a must know. Must know. If you're going to use the other method, this is what you must know. And we know that the s equals sum of the roots and p equals product of the roots. Sum of the roots, product of the roots is the other method that we can use. Sum of the roots, product of the roots will give you the same equation. Now I'm going to do it with the negative 2/3 and the 1/2, just to show you that the equation, it works. And we're going to get by the same equation, 6x squared plus x minus 2, when we make the adjustment. Remember, we have to adjust them to get rid of all the fractions. That is the key. You have to adjust them to get rid of the fractions. All right, so that's your equation. That's your quadratic equation, can always be written like that. X squared minus the sum of the roots plus the product of the roots. All right, so see it here now. Now, in this example, remember, let's use the blue for the example. Remember that the roots are minus 2/3 and half. All right, so we're going to work out the sum and we're going to work out the product, and then we're going to drop them in the equation. So the sum of those two roots, which is S, would be minus 2/3 plus half. We're going to add those two and make it into one fraction. If we want to make it into one fraction, we need the two denominators to be the same. All right, so this one, I'm going to multiply this one by 2/2. I'm going to multiply, let me space it out so you can see better. So put back the blue and put back the half. I'm going to put back the plus half out here for the sum. So to make the two denominators be 6, we want the two denominators to be the same. Multiply this first fraction here by 2/2 and multiply this one by 3/3. That's going to make the two denominators the same. Two denominators become 6. So the sum therefore is equal to minus 4/6 plus 3/6. So since the two denominators are the same now, we can just do the 3 minus 4. And the 3 minus 4 is negative 1/6. So that is the sum that is coming right here. All right? Then I need the product now of the two roots. The product, which is P. The P that is going into this equation now will be the product of negative 2/3. I can just multiply them straight. Negative 2/3 times half. Negative 2/3 times half. And because this is something over 6, I'm going to keep everything over 6. Right? So I'm going to just leave this as minus 2/6. So it's easier to handle. Right? So it's the minus 2 times the 1 gives me this minus 2 up here. And the 3 times 2 gives me the 6. Now, if I wanted, I could have put negative 1/3. I'll get the final answer the same anyway. What happens now? When I do that, the equation up here, let's go back for the purple now. Going back to the equation now. The equation with those two roots is therefore x squared minus, remember the s now is negative 1/6, and negative 1/6 times x. Don't forget that, times x. And then you're adding the minus 2/6. Now, if you're adding minus 2/6, it's the same as just saying minus 2/6. Right? It's the same as saying minus 2/6. Now we can say the plus p. The plus p is minus 2/6. So the plus p is minus 2/6, right? So the plus p is minus 2/6. And everybody equals 0. And then all we have to do now is look at the minus here, it makes it a plus. Let's look at it, you get x squared plus, you're going to get 1/6x minus 2/6 equals 0. And then to make it have whole numbers, I just need to multiply now this equation by 6. Multiply the entire equation by 6 to get rid of those fractions. Right? So multiply each value by 6, so you get 6x squared plus the 6 times 1, 6 cancel that, you get x. The 6 years cancelled when you multiply by 6, you get minus 2 equals 0. So you see that you get the same equation that we had over on this side. Same equation. See it there? Same equation. Then after you get the same equation now, you go back and you look at the graph. Look at that graph or that graph, whichever one you have, and you proceed on to your answer just the same. But the bottom line is that you get the same equation. That is the important thing. We end up with the same equation. But understand that? So remember now, the formula that you have to know for this one is this guy right here. This formula right here. X squared minus the sum of the roots times x plus the product of the roots equals 0. So we're gonna do the next questions two ways. Each of the next question, we're gonna do them two ways, all right? So let's look at it. So these are the next two questions. These are the next two questions. So let me stretch this out so we can do the two ways. So we'll do this one first. Oh, it's made that smaller. Didn't want this to be smaller. I want it to stretch this thing. All right, it's not working, but it doesn't matter. So I want to do that one, right? F of x. So for f of x, let's do this question now. We're gonna do it two ways. So f of x, one root is -1, and the other root is 3. So remember, from the root, we go to the equation first. We're using the first method. The equation is x minus r1 times x minus r2 equals 0. That's using the first method that I showed you. So it will be x minus r1 is -1 bracket times x minus r2 is 3 equals 0. That will be the equation. The minus minus is plus, so it will be x plus 1 times x minus 3 equals 0. And then we need to expand this now to get it out in the standard form. So it will be the x times the x first, remember, which is x squared. Then the third term is 1 times minus 3. So when it's minus 3 out here equals 0. And then the middle term, remember now, is the far product. Use already. The sum of the far product and the near product. And we can just work it out straight. So basically that is minus 3x. Up here is minus 3x. Go back for the red. So we can see it. Up here is minus 3x is that product. And down here is plus 1x. Minus 3 plus 1 is -2. Minus 3 plus 1 is -2x. All right, so that is the equation. Now, this equation matches the function because if you notice, a smile graph you have, you know. So since you have a smile graph, it matches the smile graph. In addition to that, if you look to the graph here, the y-axis intercept on the graph, if you look at it, is negative, and this is also negative. See it here? Over here, this is negative. Right? That is negative, and it matches what we see on the graph. So right now the graph matches the function. So because the graph matches the function, so we can say this equation matches the function graph. Hold on a second. Let's take this call. I want to pause the video. This technology not easy sometimes. Let me try if I can get back on. Let me try to get back on now. Let's see. Just give me a second. I'm working it out, guys. My tablet jumped off. Fortunately, I have my phone connected as well, so phone has taken over as host. So I'm just trying to join back with the tablet. I don't know why it jumped off. Okay. All right. I think I'm back. So let me get about the host. Okay. All right. All right, we're back. All right, so let me start by the sharing. Start by the recording, but this recording is going to be messed up. That's what usually happens. Well, it actually is recording. All right, so it says it's recording. All right, so so I was saying no, because this function that we're working on, this function matches this equation. It means that all we need to do is write f of x, which I've done here. So that is a function for that one. All right. Well, let me do the other method now. Let me do the same thing, the same question, the other method. And the important thing is that we're going to end up with the same equation. And then the conclusion part down here will be the same. It's a matter of getting to the equation. So the other method, as I said, is to say the equation. So up here we said the equation was x minus r1, x minus r2. You know the two roots. The other method is the roots again are r1 equals minus 1, r2 equals 3. The equation is x squared minus the sum of those two roots times x plus the product of those two roots equals 0. All right, and so it will be x squared minus, and the sum will be minus 1 plus 3 times x plus the product would be minus 1 times 3 equals 0. Simple as that. Now what is this? 3 minus 1 is 2. So it will be x squared minus 2x. And 3 times minus 1 is negative 3. So it's plus negative 3. Plus negative 3 is the same as minus 3 equals 0. So you see we're getting the same equation as we did right here. Well, here. same equation. So you see this way maybe is a little bit even quicker. Right? That's that method. And again, the equation matches a function. The equation matches the function graph. Matches a function graph. So because it matches a function graph, we can say therefore the function is f of x equals x squared minus 2x minus 3. And leave off the equals 0. So what did we do? We go from the roots. We go from the roots up here to the equation first, and then from the equation we go to the function by observing that the equation matches the function. All right, let's look at the second one. Let's look at the next one where the roots are negative a half, this one now, negative a half and 5. Let's look at that one. All right, I'm going to do the two methods again. All right, let's clear this. All right, so we're looking at the next one now. Second one now. Here we're doing g of x, doing the function g of x now. And for g of x, the roots are r1 equals half, r2 equals 5. Let's go to make the two methods. The first method is the x minus r1, x minus r2. So the equation is x minus r1 times x minus r2 equals 0. The equation would take that form. All right, and so it will be x minus half times x minus 5 equals 0. Now the question would more than likely say that the coefficient in the standard form must be whole number values, integer values. So we don't want this half in there. We want to get rid of the fraction. To get rid of that half, we'd have to multiply both sides of the equation by 2. Multiply both sides of the equation by 2. But you're applying this 2 to this bracket alone. That's the important thing to remember. And let me show you why you have to apply it to just the first bracket. Look, if I'm doing 2 times 3 times 5, for example, 2 times 3 times 5 is equal to 30, you know. Right? Now I can put these two together and make it 6 times 5, which is still 30. Or I can put the 2 with the 5 and make it 3 times 10, which is still equal to the 30. So either I do the 2 with the 3 or I do the 2 with the 5. I cannot do both. If I do both of them, I make it 6 times 10. That will be 60. So if I apply the 2 to the 3 and get 6, and then apply the 2 to the 5 and get 10, I'm getting 60, which is wrong. So when you have the product of three things like this, this times this times this, is that I apply this to the first one, or you apply it to the second one. You cannot apply it to both of them. But understand that? So that's why I'm saying you apply the 2 to the first bracket alone. You cannot apply it to both. All right, so I hope that clears that up, why I'm applying it to the first one only. So now I'm multiply both sides by 2. I'm applying the 2 to the first one alone, the first bracket alone. And then now this then becomes 2x minus 1. Oh, I get that. 2 times x is 2x down here. And 2 times a half is 1. Negative 2 times a half is 1. All right, it's like the 2 cancels this 2, leave me with 1. Right? And then this bracket comes back as x minus 5. And then on this side, 0 times 2 is just still equal to 0. So my equation becomes that. All right, without the fraction. And then we're going to expand it now. Remember now, this times this first gives me 2x squared. And the last term is minus 1 times minus 5, which is positive 5 plus 5 equals 0. And remember now, for the middle term, let's go shortcut again. Let's do it again. It's far product and near product. The far product is minus 10x, and the near product is minus 1x. So my middle term is the sum of those two. which is minus 11x. Minus 11x is my middle term. So that's my equation. But remember, you know, I'm doing this function now, you know. I have a front function. I'm doing this function now, you know. The second one I'm doing, you know, is g of x graph I'm doing. Now that equation does not match the function. So let's write it out. Equation does not match the function. Graph does not match the function graph, right? How we know it don't match? Because this is a positive x squared term, which will be for a smile. This will be for a smile, but we actually have a frown. So that is why they don't match. In addition to that, my y-axis intercept for this one would have to be a positive. This graph has a negative y-axis intercept, right? So they don't match. So to get them to match, what I do, I multiply by -1. So I take this equation and I multiply by -1. When I multiply by the -1, I multiply the equation by -1, it's going to match because it becomes negative 2x squared plus 11x minus 5 equals 0. Then this now is a match. This now is a match. Right? And since we know our match, we can now write the function. So therefore, the function g of x. Therefore, g of x is minus 2x squared plus 11x minus 5. And that is the function g of x. All right, let's do the other method. All right, if you don't understand something, just let me know, guys. Let's do the other method. So remember now, this is using the method where we write the equation as x minus r1, x minus r2 equals 0. Start this way. That's one method. The other method is when we use the sum and the product of the roots formula. All right, so looking at the other method now. So let's go. Almost like we're starting over. So again, the roots, doing g of x again. And in this case, the roots are r1 equals half, r2 equals 5. All right, I'm using the equation as x squared minus the sum of the roots times x plus the product of the roots equals 0. This is the one that we're using now. We're using this format, this method. Right? It's up to you whichever one you want to use. Whichever one you feel more comfortable with, you can use it. We're forming the equation from the roots. You have two ways to do it. You can use this, or you can use the other one. This one is the sum and product of the roots. The other one is the factor form, x minus r1, x minus r2. All right? So for this one, I need to find the s and the p. Let's write them out separately. All right? So the s, the sum of the roots, which is s, would be equal to a half plus 5. Half plus 5 is simply half plus 10 over 2. Because the 5 is the same as 10 over 2, which then becomes 11 over 2. And then the product of the two roots, which is p. For some reason, I think I like this method better. I don't know why. Product of the two roots, which is p, would be equal to, I know this method good for you now because you're actually gonna use this method if you decide to do add maths and pure maths, this second method. All right. So the product of the two roots will be half times 5. And the 5 there is same as 5 over 1, right? Half times 5. And so that becomes 5 over 2. All right, simple as that. And therefore, this equation now becomes, let's draw back for the purple now. It becomes x squared minus the sum of the roots, which is 11 over 2, times x. Don't people always forget to put the times x. Plus the product of the root, which is plus 5 over 2 equals 0. That becomes the equation. And I have to do now to get rid of the fraction, because the question will say they don't want any fractions, they want a whole number of values. All I need to do now is multiply this equation by a 2 to get rid of those halves, the fraction there. I multiply the equation by 2 right there, then to become x squared minus 11x plus 5 equals 0. So that's the equation that I got in the first place up here. Remember, where was it? It's here. Same equation that I got right here. 2x squared minus 11x plus 5. So we get the same equation. All right, and then when we reach equation now, we have to look to see if the equation matches the graph. Remember, we're doing the g of x graph, you know, on the right side here. Right, so we have to say it again. This equation does not, remember, you know, this is a smiley equation, but we have a front graph, right? Does not match the function as presented on the graph. And to get it to match, we need to multiply by the two roots are the same, but the graph don't match. So to get it to match, we just need to flip it by multiplying by a -1. So multiply the equation. Let me write it like this. So to get it to match, we multiply this equation by a -1. So we can get a front graph. And when we do that, we get the same thing as we did before. We get the minus x squared plus 11x minus 5 equals 0. Where we know this now is a match. And since we know about match, we can say therefore the function is, function g of x, that graph function is negative x squared plus 11x minus 5. Don't put that equals 0 now. We're trying to get the function. What did we do? We started from the roots up here. It's a blue ink, show that are the green. We started from the roots. We came down from the roots. And we go all the way down to the equation here. But the equation never matched. So we go to the right equation that matches. So we go from the roots to the equation. See it there? From the roots to the equation. And then now, from the equation, we could write the function. We're going in the opposite direction. Remember, the function is the entire graph. The equation gives you only the roots. So from the roots to the equation, and then from the equation, we deduce the function that matches the equation. Basically, that's that for that topic. All right. It's now 1 o'clock. We'll still have one topic left to do for the day. So 10 minutes to 1. We'll still have simultaneous equation. Remember, we're going to practice some questions tomorrow. So let me start with the simultaneous equations today. Right? And tomorrow we will do some practice questions on both this and simultaneous equation. But I want to do a couple questions on simultaneous equations today. But this is the first part, deriving the quadratic function from the roots. So we have finished the first part of what we're doing today, right? Which is a topic in itself. All right. So you're gonna have classwork that will on Wednesday that will have two things in it: deriving quadratic function from the roots and also simultaneous equation. But we're not doing the regular simultaneous equation. We're doing the simultaneous equation that lead a quadratic equation. So they call it quadratic simultaneous equation. All right. So if you look here on the slide, you'll see what I'm talking about right there. All right, so this is what I'm talking about right here. So this is solving simultaneous equation that lead to a quadratic equation. That's what we're looking at now. solving simultaneous equation that lead to a quadratic equation. Well, let me see this and give you a little background of what I'm talking about. All right, let me give you a little bit of background so you can understand what I'm talking about. So this is simultaneous equations, but it's a type that leads to a quadratic equation. Now, simultaneous equation really is about, in simple terms, it's like you're trying to find the point of intersection of two functions, two graph functions, two functions in a graph. So for example, if I have a y-axis and an x-axis, right? And I have two lines on that graph, one going so and one going so, right? So this equation might be x plus 2y equals 4. And this equation might be y equals 2x plus 3, for example. All right, so I have those two equations for those two graphs. And I have those two equations. So the two equations are y equals 2x plus 3. That's 2x plus 3. That's the equation for this line up here, as we can see. And we have x plus 2y equals 4. That's the equation for this second line. Now, when you solve these two lines simultaneously, right, you're basically trying to find this point where the two of them occur simultaneously. You're trying to find a point that satisfies two equations, the point that is on both equations. That's what we mean by solving them simultaneously. And in this case, it's only 1 point. So you're going to get one x value and one y value. I'm not working them out now to see what they are, but you get an x value here and a y value here when you solve them simultaneously. Now that is two linear simultaneous equations because we're talking about two lines. And two lines really will have 1 point of intersection if they're not parallel or if they are not the same line. So two different lines that are not parallel can only have 1 point of intersection. So when you solve these two lines, you're getting 1 point. 1 point as your answer. We're not talking about that today. What we're talking about today is a case where you have a line and a curve. So in this case now, what we're talking about today is the one where we have, for example, like a quadratic curve, like for example, a smile curve, and we also have a line. Now again, the line will have a linear equation, like for example, y equals 2x plus 5. But the curve will have a quadratic-like equation or some curve-like equation. It don't have to be quadratic like quadratic, but some curve-like equation. Like for example, the curve might be y. Let's say it's a quadratic. The curve might be something like y equals 2x squared minus 5x plus 7, for example. Right? Just making up something random. So that's a line and a curve. And what is happening here is that the two equations would have been y equals 2x squared minus 5x plus 7. That's the equation of the curve. And the line is y equals 2x plus 5. That's the equation of a line. And that's what they're giving CSEC. One is a line and one is a curve. And when you solve these two, they're talking about the types that is going to give you a quadratic function. When you try to solve these two equations, right, by some method, whether elimination or substitution, but we're going to be using mainly substitution. They are going to lead to a quadratic equation of the form quadratic equation. When you try to solve them, we're going to end up with a quadratic equation in the form ax squared plus bx plus c equals 0. And what do you know about solving quadratic equation? They give you two x values. Now, one of the x values is going to be for this point, and the other x value is going to be for this point. You're going to get two x values, like x1 and x2. And after you get those two x values, x1 for one point and x2 for the other point, right? You also need to know the two y values. So after you get these two x values, you're going to substitute this x value back in the line equation to get the first y value there. And then you use this same x value back in the line equation, and it will tell you what the y value is here. So basically, that's what we're doing. All right, and you're gonna get 2 points of intersection. But because you're getting two x values, you have to get a quadratic equation. Remember, it's a quadratic equation that can give you 2x values. All right. Now, the possibility exists, that you can have other curves and lines, like for example, you could have a curve that goes like that, for example. Let me draw it different. You can have a curve that goes like this, for example, and then you can have a line. Let me draw it different again. Let's use the blue. So you can have a curve that goes like that, like a cubic curve, and then you can have a line going like that, and then you'll have 3 points of intersection there. So you solve these two equations, now you will end up getting a cubic equation with a x cubed term in it. X cubed plus like ax cubed plus bx squared plus cx plus d equals 0. Because when you solve this, you're going to get 3x values. Cubic give you 3. x1, x2, x3. Will be 3x values, one for here, one for here, one for here. Right? If you solve this line and this curve simultaneously. But CSEC not giving you this type with 3. Because remember, cubic equations is not on your syllabus or CSEC. So the type that you will get is a type like up here, where you're going to end up with a quadratic equation. And that's why we say the topic is simultaneous equation that lead you to a quadratic equation. That's what the topic is written, because that is the type that you will get at this level. All right, so we're talking about a line and a curve. It always will be a line and a curve, right? They always will be a line and a curve. The fact is, two curves can have 2 points of intersection too. Just making you understand what does that mean, right? So you can actually have a case. We have, for example, a curve going like this, and another curve maybe going like that. And you see, two curves can intersect at 2 points as well. If you try to solve these two curves simultaneously, you're going to end up with a quadratic. Why? You're going to end up with a quadratic because there are 2 points of intersection there. And a quadratic will solve and give you those 2 points. All right? But our mission today is the one that leads to quadratic. All right? That's what we're doing today. Okay. So this was a new thing. Good. So I don't have to save this. Right. So today now we're doing simultaneous equation of a line and a curve. And we suppose we're gonna get a quadratic. That's the type looking at. So what we're saying here, we're going straight into what you're looking at the slide is straight into the method that we will learn. Now, persons who learn simultaneous equations already more than likely would have learned simultaneous equations with 2 lines. The teachers tell you that you have 2 methods that you can use. You can use a method of elimination, or you can use a method of substitution, right? Now, that's for 2 lines. You can use either one freely. For the line and curve, I'm telling you that it is most times, it is better to use substitution. All right, most times. There are a few that you can use elimination with, but when in doubt, substitution is the better method to use for these. All right, so we're saying here, when solving simultaneous equation of a line and a curve, we use substitution to produce a quadratic equation. So remember, when we use a substitution, we're going to end up with a quadratic equation whose roots, when we solve a quadratic equation, the roots, the answers that we get are the coordinates of the intersecting points, point of intersection. All right? And there are 3 possibilities for your syllabus. 3 possibilities. What are those possibilities? First possibility is that you can have 2 points of intersection, 2 clear points of intersection between a line and a curve. And we can see it here. We end up with a line and a curve there, and you put them together to solve it. You're going to lead it to a quadratic equation that will give you 2 roots, basically. So this is equivalent to that. All right? That's the first possibility. All right? So this is like an application topic for the quadratics that we have learned so far. The other possibility is that the line can touch the curve at a single point only. That's why the word touch is right here. In that case, the line is a tangent to the curve, and you can see it on this diagram. So the line is only one point of contact. When you have one point of contact, you're still going to get a quadratic equation, right? Because it's a line and a curve. But when you get the quadratic equation, the two roots now are going to be equal roots. See? Equal roots, because it's only one point of contact. Right? I explained the other day that it is equivalent to pushing this graph upwards so that these two roots come closer in towards each other. When the graph reaches here, the two roots now are equal. All right, that is what is happening down here, but it's still two roots you get. When you're solving simultaneous equation between a line and a curve, and you get equal roots, it means that the line is a tangent to the curve. The line touches the curve at the one point only. All right, and the other possibility, other thing that can happen is that the line don't touch the curve at all, as we can see right here. The line and the curve not touching at all, they're not touching. In that case, you're still going to get a quadratic equation, but then that quadratic equation will not have any real roots, because in reality, the line and the curve don't touch. And that is equivalent now to a quadratic graph where the quadratic function is entirely above the x-axis. It don't touch x-axis, and so there are no roots. So by roots are the points where touch x-axis. No, that's why we tend to use the word roots to make that connection. That's why we use the word roots instead of x-axis intercept. But in that case, the roots are imaginary roots. Good thing though is that CSEC won't give you this one to do, but the last one. CSEC will only give you the top two. So they give you quadratic equation where you're getting two different roots, or they give you the second one where you're getting two equal roots. Remember, if you get two equal roots, sometimes CSEC will ask you, what is the geometric property between the line and the curve? That geometric property is going to be that the line is a tangent to the curve. All right, so I'm telling you that from now. It's something you need to remember. If you solve simultaneously a line and a curve, you solve the equation for a line and a curve simultaneously, and you're getting only one root or equal roots, that means there's only one point of contact. The line touches the curve at one point, meaning the line is a tangent to the curve. And this is something that you need to remember. All right, something that you need to remember. All right, so the possibility exists that you can get either 1 or 2. You won't get 3 in your syllabus. All right, to do, but you're not able to deal with imaginary roots. And then now it's a matter of doing some examples, right? And this take a note down here says we must remember we substitute after we get the equation. I will start to get the equation. We'll get the x values alone first. But remember to substitute back in the line. Don't substitute back in the curve. Always substitute back in the line to get the other two values, the other two y values. Sometimes we'll find the y values first. Most times we'll find the x values first. And then we'll substitute in the line to get the corresponding y values. But then sometimes we'll find the y values first. All right, but what we're going to do now, we're going to do a couple of examples. All right, so there are some examples on this page right here that you're looking at. But I want to take a screenshot of this page. I think these are some of the same questions that are in the homework. All right. These are some of the same questions that are in the homework. Take a screenshot because I wanted to do these questions for homework. But I'm going to bring up some other questions first to practice from. All right. So just take a screenshot so you can look at these questions. All right. For those of you who have the handout already, you're looking at homework number 3. All right. Looking at homework number 3. So let me come out of this, go into here, and we're talking about homework number 3, quadratics homework. Let me show you what I'm talking about. I'm going to do a couple questions, right? I'm going to do a couple questions and then, yeah. All right, so sit here, homework number 3 down here on the right over here. Those are some other simultaneous equations that I wanted to practice. So those of you who don't have the handout yet, you can screenshot that and do those questions on the right. Homework number 3. All right, I think 2 of these questions are in the list that I just showed you. And then it continues onto page 3, where you are now doing these questions up to 4. These questions over here. All right, those now are the quadratic questions, where application of a quadratic question where they give you the roots. Well, these two are simultaneous equation. These two are simultaneous equation, but these two now are the questions where they give you the roots. You see, you know the roots, and they're asking you to find the function right here. You see that? They put P, Q, and R. All right. So you look at the graph and you see the roots, and they're asking to find the P, Q, and R. Same thing down here. This one now is similar. They give you the function this time. They're asking some other question. All right. So that is it. I think there's also a homework thing. Let's see. So the homework is just that alone. All right, that's a homework. Screenshot this as well. So these are other homework questions right here to find those functions, right? So screenshot that as well. That's the wrong thing. Right, so screenshot that as well, guys. So you can do those questions as homework as well. So the question that the 4 are the same homework number 3, the 4 that you see in there, and number 3 are to get the function f of x and g of x from those two roots. All right, so I want you to practice those for homework. But let me get to the worksheet now that we're going to do a couple questions from. Let me see if I can find it. All right, let's bear with me. Let me find it. Discard that. I think it is in images up here. And it is right. Where is it? Where is it? I'm not sure about this. Is that? Okay, that's it. Right, so these are a couple questions. You can screenshot this as well, guys. Some additional questions for us to do. I'm going to do a couple of these questions now, just for you to get a feel and, look at how the questions can be done. All right, the substitution method. So let me do a couple of these questions now. All right, so let me look at the first one, question 1. All right, so let me screenshot. Let me take a picture of this so we can work it. So we're going to do this simultaneous equation, question 1. We're doing these two equations to start. All right, show you how this will be done. So let me bring up a note to do it in. All right, yeah, so we're doing this. We have simultaneous equations right here now. All right, pay attention now. So we're solving the line and the curve. Now, the line equation, you have to be able to identify which one's a line, which one is a curve. So let me tell you, so the curves usually have x squared in them, or they might have y squared, or they might have x times y, or they might have x over y. Yeah, curves usually have those, right? X squared, y squared, the product of x and y, or the quotient of x and y. Right? Usually that's what they have in them, and you can identify them that way. Curves. Right? The lines usually just have a y term and an x term separate from each other, and it can be written in the form y equals mx plus c. So with the coordinate geometry, we'll start the lines. We'll see that. But the curves usually have. That's so you can know which one is a curve. I would tend to substitute the line into the curve. Remember, line into the curve. That's the method mainly that we use it. The line equation into the curve equation. All right, so let's look at these two. So we have y equals 2x plus 1. This one clearly is the line. And we have x squared plus y squared equals 10. This one clearly is a curve. All right. So the method, as I said, is to try to substitute for one of the variables, the line equation, into the curve equation. Now, this one set out friendly for us already because it already has y alone as a subject. Because it has y alone as a subject, this is saying y is equal to, we can take this and replace the y right here. because the line is saying y equals this, 2x plus 1. So it means that we can take the y, 2x plus 1, and replace, put it right in there where the y is, and then we solve. We're gonna get an equation with x alone in it. So let me go through it now. That is the approach that we use. All right. So since the line already has y as a subject, we're gonna substitute. SUB means substitute. Substitute the line. Substitute the line equation into the curve equation for the y value. And so the curve equation becomes x squared plus 2x plus 1. That's where the y was. And you put back the square equals 10. And then that's a quadratic equation in a basic form. We just need to expand it out and put it in the standard form and solve it. Now, the important thing now is how do you expand this perfect square right there? Let me just break away now and show you quickly how you expand that perfect square. All right, over here. I'm going to show you quickly. So if you have a plus b all squared, the simple result for this is that it is equal to a squared plus 2 times ab plus b squared. Plenty of people believe it would be just be a squared plus b squared, but no, that is not it. All right? Why is it so that is not the case? Let me show you this one time. I want to show you down here. All right? Now, a plus b all squared really is the same as a plus b times a plus b. And we have double brackets like that to multiply. Right? Each value in the first bracket must multiply by each value in the second bracket. So you have to multiply the a times the a, and then the a times the b. And you have to multiply the b times the a, and then the b times the b. That's what you have to do, right? So if I go and I do that, first one will be the a times the a, which is a squared. And then I have a times b, which is ab. And then I have b times a. Now, b times a is really ba now. But ba really is the same as ab. So instead of writing ba, I can write ab. And then the b times b is b squared. B squared. And so you see you have 2 times ab in there. That's why we have that 2ab. 2 times ab. So you see it becomes a squared plus 2ab plus b squared. And this is one people always tend to forget when you have that perfect square. You see this middle term, we refer to it right at the top. We refer to it as twice the product of the 2. Twice the product of the 2. When I say the 2, I mean the a and the b. Twice the product of a and b. Because two things you have in the bracket are a and b. Right? So how do we do twice the product of the 2? You multiply them first, and then you double what you get. That's how you do twice the product of the 2. Right? So I'm showing you the short way right away, and not take it, and not baby in here. You're doing CSEC, so not treating like babies. So what do you know? I'm gonna expand this perfect square here first. All right. So it's gonna become x squared. That is this x squared, right? And I'm expanding this now. So already know. Plus first term squared. When I square that, I'm gonna get 4x squared. First term squared. Twice the product of a 2. How do twice the product of a 2? Multiply them first and then double it. When I multiply them, I get 2x and then I double it to 4x. That's how we do it. All right? Multiply them first and then double it. And so my middle term is 4x. And then the 1 squared is 1. So it's plus 1. That's what I get when I multiply that perfect square equals 10. All right? So far, so good. So this is first term squared. This is twice the product of the 2. When we get twice the product of the 2, multiply the 2x times the 1 to get 2x, and then double it to 4x. And that's how we get the 4x. Multiply them first and then double it. twice the product of the two. Multiply them first and then double what you get. All right, that is all you do, twice the product of the two. All right, so let's go now. So the x squared plus the 4x is 5x. X squared plus the 4x squared is 5x squared. This is the only x term that I have there, so that is now plus 4x. And I'm going to carry over this 10 and subtract it from the 1 and get negative 9. So I'm going to get minus 9 equals 0. All right, and then it's just a matter of factorizing this now. All right, so I'm not going to bother to go through the process of factorizing. I'm going to just try and do it a shortcut method, right? I don't want to spend time splitting middle term. I don't want to spend time splitting middle term and all that. Remember this. No problem. Let's do it. So it's 5 times 9. 5 times minus 9 is minus 45. Factors of minus 45 that add to positive 4. Those factors of minus 95 that add to positive 4 is clearly 9 and 5. Give the larger one the plus and the smaller one the minus. All right. So therefore, our equation becomes 5x squared minus 5x from this plus 9x from this minus 9, that's minus 9 equals 0. I'm going to factorize these two. I get the 5x into x minus 1. Put back the x minus 1 over here equals 0. Factorize x in here. So I take out a plus 9. And then it's this and that times the common factor. So I get 5x plus 9 in that bracket times x minus 1 equals 0. All right, so the two x values I'm getting is that x equals minus 9 over 5 from this one. Everybody can see that. I'm getting x equals 1 from this one. But I can see that? Far so good? Remember now, the line equation. The line equation is y equals 2x plus 1. I'm not finished as yet. I have to find the y value to go with this and the y value to go with that. So what do we do? Substitute these values into the line equation. So you're going to substitute into the line equation. The line equation is y equals 2x plus 1. Firstly, at x equals minus 9 over 5, that's at this point, the y value is equal to 2 times minus 9 over 5 plus 1. This becomes minus 18 over 5 plus the 1 right here is the same as 5 over 5. And so that is minus 13 over 5. So it means that one point of intersection is this x value with this y value right there. So that is one point where the line and the curve meet. Minus 9 over 5 minus 13 over 5 is one point of intersection of this line and this curve that we're working out. All right. Then we're moving down with the next point. The next point is where x equals 1. So we can say at the point where x equals 1, the y value is 2 times 1. See here, this is the line equation we're using. 2 times 1 plus 1. 2 times 1 plus 1 is 3. So the x value is 1 and the y value is 3 at that other point of intersection. And so that is the point 1, 3. That is the point 1, 3. All right, that's that. Everybody good? Everybody okay? Let's do a couple more. Everybody can hear me? Answer, let me know that you're still there now, guys.
Yes.
All right, good.
Yes,
let us do another one. More math equals better math. So let's do another one. All right, let's do another one. So let's look back at the sheet. Let me save this. No, we can do another one right on this page. So let me look back at the sheet. Where's that sheet? Right, this is it. This sheet. All right, let's do another one. We have to look at adjustments. So we'll finish with this one. One of these have y's. All right. I want to have x squared in it. So this one have x squared in it. This one is x squared. This one. This one. All right, let's do. I'm going to choose one in a second. X squared, x squared. These kind of straightforward. And let us do number 8. Let's do number 8. All right, let us do number 8. This one. All right, that's a little bit different. All right, move the mic back now, please. Move back the mic. All right, let us do this one now. All right, line and curve again. All right, so we're solving simultaneous to that line and that curve. So again, they've given us y as a subject. They don't give you y as a subject, you have to transpose it and make y the subject. So maybe try the one like that afterwards. So this one, they give us y equals 2x minus 1. This clearly is our line. And they give us x squared plus xy equals 24. This one clearly is our curve. See it as an x squared term and an xy term. That is our curve, right? So again, because this one already has y as a subject, we can take that and substitute for the y right here. Like that. Or replace the y right here. And the line is saying y equals that. So we can substitute the line equation into the curve equation for the y right there. All right, so that's the method we're using, a substitution method. All right, so ready. We're gonna substitute the line into the curve for the y value. We're substituting for the y value on the curve. And the line is saying y equals 2x minus 1. And so the curve then becomes x squared plus x. Where the y is, I'm putting 2x minus 1 for the y, and this is now equal to 24. So now I have a quadratic equation that is in a basic form. I just need to know, expand it out, simplify it down to a standard form, and then I solve it. All right, and most of these, you don't need a quadratic formula. Most of these can be solved using factorization. Right, in the work that I gave you, the last set, you might have to use, I'm going to show you. When I go back to the sheet, I'll show you. But I just need to solve this now. So this is a straight expansion right here. Nothing magical. So this becomes x squared plus 2x squared minus x. And then this 24, I'm going to just bring it over one time and put minus 24 equals 0. Minus 24 equals 0. All right. And then I'm putting these two x squared terms together. So I get 3x squared minus x minus 24 equals 0. And then I want to factorize this. All right, I want to factorize this. So the same procedure again to factorize it. So factorize this. I'm going to multiply 2 in coefficient, which is 3 times minus 24. What is that? 72. That's 72 minus 72. I want factors of minus 72 that add to the middle coefficient, which is negative 1. Negative 1. And I think that is 9 and 8. 9 and 8. So the factors of those are 8 and 9. Give the larger one the negative. Negative and a smaller one the positive. All right. And so I found them because this would be equal to my -1. So I found them already. So I'm going to come down now, and this is going to become 3x squared. Put the -9 with the 3. So I'm going to get minus 9x and put the 8 with the 24. So I'm going to put the minus 9x plus 8x minus 24 equals 0. I'm going to do highest factor in the first two terms, which is 3x. Out of this, give me x. Out of this, give me 3. Same thing must end back up in the bracket over here. X minus 3. And clearly the plus 8 coming out here. Alright, so I'm getting plus 8. Yeah, check it. Plus 8 times the minus 3 is minus 24. So you know that you're good. Don't forget to put the equals 0. And here factorize. This and this times the common factor. Alright, so you get 3x plus 8 times the common factor of x minus 3 equals 0. So we all know that this one is equals 0. We're going to get the x equals q over the minus q over the 8 first and then divide by the 3. Alright, so it's going to give me x equals minus 8 over 3. But understand that? Q over the 8, you get minus 8 and then divide under the 3. Alright, and for this one, I'm simply going to get x equals 3. Q over the negative 3 becomes positive 3. With equals 0. So those are the two. Remember, I don't finish there. You want to find a y value to go with this and find a y value to go with this. Because remember, I know we are solving these two equations simultaneously. So you need to find the two y values. So don't forget what we're doing. Right? We're not just solving a quadratic equation. So all we have to do now, substitute into the line one. Right? So we're going to substitute these two x values now into the line equation, which is y equals 2x minus 1. All right. Firstly, at the point where x equals negative 8 over 3, the y value becomes 2 times negative 8 over 3. That's for the x value there. I replace the negative x over 3 with the x there. For the x there, minus 1. And then we'll work it out. It becomes minus 16 over 3, and this 1, I'm going to write it as 3 over 3. So it's minus 3 over 3. And so I get minus 19 over 3. So this is my x value at that point. This is my y value at that point. All right. So I'm going to get 1 point is going to be minus 8 over 3 minus 19 over 3. All right. That's 1 point. So I need to do for this point now where x equals 3. So at x equals 3, my y value becomes, I'm putting 3 here in the line. My y value becomes 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. So that's 5. Therefore, my other point is 3, 5. So these two are my answers right there. My 2 points of intersection. All right. So that is that. Nice and easy. All right. So let me go back. And I'm going to go and we do another question still. All right. More maths equals better math. So I want to choose one next one kind of carefully. I want to do one. All right. All right. That one. Let me go back on the thing, the page. Let me set this one up, please, up here. Let me X this out. That and that. All right. All right. Let me show you. I'm going to show you some skills now. Let me do this one. All right. Yes, let's do this one. I'm going to do these two. I'm going to do this one right here that I wrote notes. I'm going to do this pair. Let's do not that. Wrong selection. I'm gonna do this one next. This that I've written out. Doing that one next that I've written out, right? That's the one that I'm doing next. Show you something with this one. Alrighty. Alright, let's do another one. What time is it now? We're gonna practice some more tomorrow now, so maybe we can just let this the last one for what time is it? 1:30 something. Can do this one and maybe one more after this, and we'll call it a day. Alright, let's do another one after this. So one that we're doing next is 2x plus 3y equals 5, which clearly is the line, and we're doing 2y squared plus xy equals 12, which clearly is the curve. Now, if you look at this one, now the line don't have x as a subject, or don't have y as a subject rate. And so you have to be smart. Remember, you want to be able to substitute in this equation, you know. Right? Now, because I have a y squared here and a y here, to me, it is easier to substitute for this x. That's the only x value in there. Substitute for that x. All right? So I'm going to make some adjustments now to make it easier for me. Right? Now, that's what I'm going to do. I'm going to write the equation with 2x as a subject. Why 2x? Because I don't want the fractions. All right? So I'm just going to leave 2x as a subject as this. So when I leave 2x as a subject, I'm going to transpose the 3y over there. All right? So that my line is going to become 2x equals, it's going to become 5 minus 3y. So I'm going to work with this as my line instead now. So I'm going to be using this as my line instead with the 2x as a subject. All right, and then for the curve, I'm going to make an adjustment to the curve as well. All right, write this lower. Write this lower down so we can see it a little clearer. So the curve was 2y plus 2y squared plus xy equals 12, and that is my curve as presented. But because I have 2x as my subject there, it would be nice if this also was a 2x. So what I'm going to do to make that a 2x, and I do have all these fractions to deal with, I don't want the fractions, I'm going to multiply this equation by a 2. If I multiply that equation by a 2, then this will become 4y squared plus 2x times y. So you see me have my 2x now, right? And equals 24. Come on, multiply this by 2 to, you know, that equals 24. So therefore, I'm now going to work with this as my curve. So this is the same line, you know, that this is, you know, right? But I just rearrange them in a friendly way, and this is the same curve, but I just put them in a more friendly manner to my process. So I'm going to substitute now for 2x, the line into the curve. So already know. So I'm going to substitute the line into the curve for 2x. I'm going to substitute for the 2x. So see it here, the line is saying 2x equals this. So I'm going to take this and bring it and replace the 2x right here. That's what I'm doing. All right, the line is saying 2x equals that. So I'm going to take that 5 minus 3y and replace the 2x in the curve right there. All right, so that way I don't have enough fractions and all these things to deal with for the substitute for 2x. All right, so you can actually do it like that. So when I do that now, this, remember, going to change in this equation. So everything else remain the same. So I'm going to get 4y squared plus, with the 2x's, I'm going to put 5 minus 3y, put back the y beside it, equals 24. So I know about quadratic, just that this is now a quadratic in the y values. So it means that I'm now finding the y values first. No wrong. I can't find the y values first. I find the x values first. So since I'm finding the y values first, when I'm finished, I have to go back and find the x values. All right. So ready now. So I'm going to solve this now the normal way, but this that I'm solving for y values first. So I'm going to expand it out. I'm going to get 4y squared. Then it's the y times the 5 right there, which gives me 5y. And then there's the y times the minus 3 right there, which gives me the negative 3y squared. And then this 24, I'm going to bring it over and put as negative 24. Negative 24, because remember, you always want your quadratic to be equal to 0. Then this y squared term minus that y squared term, that's 4 minus 3 is 1. So that is y squared. I'm going to get y squared plus 5y minus 24 equals 0. So it's pretty simple now. I want factors of 24 where the difference is 5. Oh, I know because the first term is a y squared. Remember what we did when the first term is just a squared term? And I want factors of this where because it's a minus, I want the difference to be 5. All right, I remember the 2 signs in the bracket will be different. So let's work it out. I'm going to have 2 bracketed terms like this equals 0. Y and y. Signs in the bracket are different. One is plus, one is minus. Factors of 24 where the difference is, factor of 24 where the difference is 5. Factors of 24 where the difference is 5 is 8 and 3. The larger one will have the sign of the middle term, and the smaller one, that's the negative. All right, so that's a quick way to work it out. All right, so I'm putting the plus 8 and the minus 3. And if you're not sure, you can check it. Look how we can check it quick. All right, this times this is my y squared. 8 times minus 3 is my that term. Now remember, the middle term is my far product and my near product. The near product is 8y, and the far product is minus 3y. 8y minus 3y clearly is plus 5. So I know that it factorizes good. All right? I know that it factorizes good. And this little thing over here is basically our steps in factorizing it. Right? So now that I know that it factorizes good, what are my two values? My values are y equals 8 and y equals 3. No, not 8, negative 8. Y equals negative 8. I care about the 8, it becomes negative 8. Negative 8. And this one, care about the negative 3, becomes positive 3. Y equals 3. So those are my two y values. Y equals 8. Y equals negative 8. Y equals 3. Now I need to find the corresponding x values now. And to find the corresponding x values now. Remember the line that we used was this line. All right, remember the line was 2x equals 5 minus 3y, right? So we're going to substitute into 2x equals 5 minus 3y. So we can find x values, right? Remember, after we find the 2x, we have to divide by the 2 to know what the x is, right? So firstly, at y equals negative 8, the 2y right here becomes, not 2y, the 2x, sorry, 2x right here becomes 5 minus 3 times negative 8, which is really 2x equals 5 plus 24. But I can see that because the 3 times 8 is 24, negative times negative is positive. So the 2x equals 29, and so the x equals 29 over 2. So this tells me that one of the points now, remember, the key thing here to remember now is that even though you calculated the y values first, you still have to put it second in the bracket. You have to remember that, the bracket must always have x followed by y. So for this point, it is 29 over 2, negative 8. That is one point of intersection. The second point is at y equals 3. At y equals 3, you put in the 3 here again in this equation. 2y becomes 5 minus 3 times 3. That is it, not the 2y. We keep saying y. The 2x, sorry. 2x equals 5 minus 3 times the y value here, which is 3 this time. So the 2x equals 5 minus 9. 5 minus 9 is negative 4. So the 2x equals negative 4. And so your x equals negative 2. So the second point, remember, even though we have the y value calculated first, we still have to put the x value first in the bracket. The point has to always be xy. So in that case, it is negative 2, 3. So those are your 2 points of intersection. This is one of them, and this is the other one for these two line and curve right there. All right, nice and easy. Who said the one more? Let's go to 2 o'clock. Who said the one more?
No one, sir. No.
Huh? Who said the one more?
Not me.
Oh, so Tajay said no more.
Yes, sir. I think we got this very well. So we can.
You grasp it very well. Anyway,
Yes, sir.
what thing with them are more math equals better math. In order for you to gain mastery at anything, you have to keep going. So even though you grasp it very well, more math still equals better maths. I'm sure say you're not master yet. So guess what? We're doing one more. More maths equals better maths. So let's do one more. And we'll call it a day. Right now, your exam is 2 hours 40 minutes now. You have to do 2 exams on the same day. So we do a 3-hour class, that is the least. You have to spend more than 3 hours in the exam room when you do the exam. Right? And that is one of the problems in the classroom. Most classes are like 1.5, but the exam is 2 hours 40 minutes. So when you do class every day for 1.5 hours, and then you go into an exam which is 2 hours and 40 minutes, after 1.5, you just want to sleep, you got tired. And that's why a lot of people actually sleep in exam rooms. Believe it or not, a lot of people sleep in exam rooms. All right, so come on, let's do another one. More maths equals better maths every time. Let us do another one. I'm going to do one more. I'm going to show you a little skill method with this last one, and we'll finish off here, right? I'm just going to show you a little skill method with this last one. Because you see, you grasp it, but I'm sure you don't know everything. I'm going to show you a little skill method to finish off this number 10. All right, teach you a little skill. All right, that's the number 10, and learn a little skill. Yeah, number 10. All right. Yeah, that's the number 10. So these two down here, that is left, the last two that said extended, 11 and 12, those are two that cannot be factorized. You have to use the quadratic formula, all right, for those two. All right, so those two can't factorize, but I still wanted to try them. But let us do one more. I'm not gonna follow touch J. People here still want to learn. You grasp it. I don't know about everybody. I can't speak for everybody. And even if them grasp it, I know they're not master it, because I'm sure nobody's gonna think of what I'm gonna show you now. Alright, more maths equals better maths every time. Alright, so let's do another one. Okay, right here. Wow, watch this now. I'm gonna leave it a little bit of skill before you leave to be. Alright, so we have the line and the curve again. So we have 2x plus y equals 11, which is the line. And what some people do, that's right, y as a subject and write 11 minus 2x. Right? And then you have the curve xy equals 15. And you will study 11 minus 2x and substitute it right here and proceed, right? Most persons will do that, but I'm going to show you a little bit of skill before you get into that. All right, so let's do it another way, just to show you something different. All right, so we have xy equals 15, and that is the curve. Put it lower down. Xy equals 15, and that is a curve. Now, I said to you that the majority of the time, you substitute the line equation into the curve equation. As I just said, you make y the subject and then substitute the line equation into the curve equation. But let me just show you another little skill now. Now, this one is saying xy equals 15. Now, if I can generate the xy in this equation, I can just replace it with 15. So to generate the xy up there, I'm actually going to multiply this first equation by x. When I multiply this first equation by x to generate the xy, I'm gonna get 2x squared plus xy equals 11x. But I see that? What it means that this xy that is right here, I can also replace it with the 15 because the curve is saying xy equals 15. So this time, I'm going to substitute for the xy. I'm going to substitute the curve into the line. All right? The line, curve into the line. All right? So let's remind ourselves that the line can still be y equals 11 minus 2x. It is easier for us to use this in the end to find the y values. But for now, I'm going to substitute for the xy. So see here, substitute for the xy. I'm doing the curve into my line adjustment. This is my line adjustment. All right, into my line adjusted. I'll show you another method. All right, substitute for the xy. And when I do that, I get 2x squared, where the xy was, I just put 15 now, equals 11x. And if I transpose it, bring over the x, the 11x, I get 2x squared minus 11x plus 15 equals 0. But I want to just break and show you if I done the substitution for the y, I would have got the same equation, right? So if I go back to the 2 and say, all right, from the line, it was, I could write y equals 11 minus 2x as my line. And my curve is xy equals 15 as my curve. I'm showing that what I've done the same thing. And if I substitute the line into my curve for y, I would have gotten that x times 11 minus 2x equals 15. And if I expand this, I will get 11x minus 2x squared equals 15. But then now, you see I have a negative x squared term there. When you're doing quadratics, you always want the x squared term to be positive. So what I would do is transpose these over onto this side instead, so that the x squared term becomes positive. All right. So when I transpose them, I will get 0 equals 2x squared. That's when this goes over. Minus 11x. That's when this goes over. And the 15 is already on that side. So I'll just put plus 15. Then if 0 equals this, it is the same as saying this 2x minus 11x plus 15 is equal to 0, which essentially is the same equation there. But guess what? I got it much quicker this way. All right. But I'm saying if you had done it this way, you'd have got the same equation. All right. So that's the skill I want to show you, that we have like the xy equations. We can multiply the line equation or one of the equations by the xy, substitute for the xy and eliminate the y that way. All right. So we want to factorize this now. And since we're undoing stuff another way, let us factorize this another way for practice. I could just factorize it. So it is 2 factors equals 0. Or factors of 2x squared are only 2x and x. Now factors of 15, and the sum must give us 11. One way is the sum. Far product and the near product must give us 11. One way is the sum because this is a plus. So I need to put the 2 with the 3 to make it 6, and put the 5 with the x to make it 11. 2 times 3 is 6, 5 times 1 is 11, 5 times 1 is 5. Right? And then what happens is that the 2 signs in the bracket are the same. That's what that plus means. And they are both negative. So this is a negative, this is a negative. So that's like a shortcut way of factorizing. We observe your values, right? So when you get good at it, you can actually factorize them quickly like that. But you can continue to do it the method that I showed you. All right? And if you're not sure, as usual, you can check it. Let's check it. So this times this gives me that, which is good. Negative 5 times the negative 3 give me positive 15, which is good. And my middle term is the far product and the near product. The far product is negative 6x. And my near product is negative 5x. Negative 6 and negative 5 is negative 11. So I know that it factorizes good. All right. Then now, back to the equation now. This half of it is giving me that the x is equal to 5 over 2. This half of it is telling me that the x is equal to 3. Remember, don't finish it, you have to find the corresponding y value. So we basically, you can actually use this one, if you want, Okay, I could just divide by the x, but then it's always safer to use the line. So I'm going to come back and use the line. This is 11 minus 2x, right? So I'm going to substitute into the line, which is y equals 11 minus 2x. Firstly, at the point where x equals 5 over 2, y value at that point is 11 minus 2 times 5 over 2. And then this and this cancel. So you actually get 11 minus 5. 11 minus 5 is what? 6, right? 11 minus 5 is 6. So that is, you have a point where the x value is this and the y value is that. I always put x value in the bracket first. 5 over 2, 6 is 1 point. And the second point is at the point where x equals 3. At the point where x equals 3, the y value in the equation again is 11 minus 2 times 3. 2 times 3 is 6. 11 minus 6 now is 5. And so you see that the other point is 3, 5. And we can check them, Sometimes I go to check them in the other equation. Since we use a line to find them, we can check them in the curve equation, which is that curve equation is that xy equals 15. It's 15. Yeah, xy equals 15. So we can check them in xy equals 15 to see if them work. All right. So the first one, which is 5 over 2, 6. You can check them. Xy equals 15. Check them and see if xy equals 15. 5 over 2 times 6. Yes, this equals 15. Oh no. Because 2 into this was 1 time and 2 into that was 3 times. And 5 is 15, right? So that is correct. 15. So that means that the point is correct. And the other one is a 0.35, where x times y becomes 3 times 5. That's x times y. And they are actually, yes, equal to 15. So sometimes they can check to see if the answers are correct. All right. Sometimes they can actually check, see if the answers are correct. All right. So that, guys, for today. Tomorrow we shall do more maths, because more maths equals better maths. And if you want to pass exams easily, you have to study hard. Study hard, pass easily. That's how it works.
Tomorrow.
Huh?
What time tomorrow?
All right, so the aim is 3 o'clock tomorrow.
All right.
I'll let you know if there's any change. But if not 3 o'clock, then by 5 o'clock. But the aim is 3 o'clock. All right. Remember, the original time is really 5, but because school is out, we're aiming to have it at 3, so we can get it out the way earlier. All right. Let me stop this recording. All right. Nobody have any question? Boy, I go to the class and nobody asked me not even one question. Hold that. Nobody asked me one question. Let me say the explanation is so good. Nobody ever want even one question to ask. Let me stop the recording. I will talk a little bit.